Let's look at practice problem 5-3. In 5-3, we're going to use MD Solids software to analyze the truss. And to be honest, I think you'll like this compared to doing a truss by hand. So, I've got a truss. I need to know a few things about the truss before I begin. I've got 4 bays. They are each 20 feet long, and the truss is 20 feet high. The important thing here is that every one of these nodes where there's a joint needs to be on the grid. You need to set up grid spacing so that every one of those points is at the intersection of a grid line. And you'll see what that means in a minute. This case is really easy. The grid spacing horizontally is 20 feet. The vertical spacing is also 20 feet. Okay, so let's begin. I click on the MD Solids. I bring up trusses. I click on it, and I get the truss screen. Select New Truss. I left click on New Truss, and then I get the Define Truss Grid window. First thing I need to do, I set my distances to 20 feet, and each horizontally and vertically. Horizontal spacing is now 20 feet, and I have 4 spaces. My vertical spacing is also 20 feet. I only need 1 space. So I will click on the little down arrow to change that to 1. And there we go. We're okay. There is my grid. 1, 2, 3, 4 spaces. And 1 space high of 20 feet. Let's bring back the picture of the actual truss itself. I'm going to let that sit off to the side so I can see it. And now I'm going to make sure I've got Create and Members, and I'm going to draw the members in for the truss. Now, one thing you might be tempted to do is grab one end and try to drag it all the way to the other side. That will not work. You need to actually drag and drop a node for every one of these members. So, left mouse down, hold, release. Left mouse down, hold, release. I get anywhere in the vicinity, left mouse down, hold, and if I'm anywhere close to that grid coordinate down there, it just let go. It'll snap right to it. Left mouse, drag, release. Now let's do the 3 verticals. Left mouse, drag, release. Left mouse, drag, release. Left mouse, drag, release. The order means absolutely nothing. It doesn't matter what you do. And I will stop saying left mouse, drag, release. But that's what I'm doing for every one of these. Click, drag, release. Click, drag, release. Notice that it also calculates the angles, which we knew were 45 because it's all 20, 20, 20, 20. Okay. The next thing I need to do, okay, my truss geometry. Now this looks a little bit higher. It's not really drawn to scale. Obviously 20 feet horizontally and 20 feet vertically are different. That's not important as long as it knows the numbers. Next, I have to put supports on the beam. So, create supports. Left mouse, pull down in the direction of the support, release. Left mouse, pull down, release. Left mouse, pull to the left, release. And you can see that this pin, because I had to pull 2 times, that ball gets converted to a pin. Now my supports are complete. Make sure that you put the pin on the correct side. If you do not, the analysis will change. In this case, not so much because there's no horizontal forces, but if there are, the pin definitely needs to be in the correct location. And finally, let's create the loads. Okay, I see in the picture that the loads are right here. That doesn't matter. You always start at the node, left mouse, drag in the down direction, type in a magnitude, 10. Loads down, 40, enter. Left mouse down, 10, enter. And there are my 3 loads. Note that there were no units. So I have to keep all of my units, 10 kips, 40 kips, 10 kips, consistent. If I put 10,000 here, and then 40 here, and then 10,000 here, that would be mixing units, pounds, kips, pounds. You do not want to do that. Okay, notice that now that all my loads are in place, the compute button is popped up. Click on it. There is your solution. 30 kips in compression, 30 kips in compression, 50 kips in tension, 50 kips in tension. There are 30 kips and 30 kips, and 0 kips are our reaction forces. One thing you want to do, I want you pull down the file menu, go down to print, give it a title. Should always be your last name first. Practice problem 5-3. This lets me know who it is. Next. I'm going to send this to an Adobe PDF file. I'm going to print it. The next thing it always asks for some reason is, what font do you want to use? And next thing I get on my computer is PP5-3. Yes, save that guy. It's converting it to a PDF file. It created it. It did all kinds of fun stuff. Get out of the way. And if I look at my PDF file, there it is. It's got Du Bois Practice Problem 5-3 in the title. You can now easily cut and paste this, or you can insert this into a Word document. If you want to cut it, okay, this defaulted to showing it in Firefox, but if you open this with Adobe, you can take a snapshot of this section of screen. I'll let you guys work on that one. One way or another, get these pictures into a Word document and then submit them for your homework assignment. That is as complicated as it gets. Okay, and of course when you change, it makes you recalculate if you get out of truss analysis mode, like when you go to print. But the thing you want to print is this picture with all the forces shown on it. Make sure that the sizes are correct, make sure the loads are correct, and make sure that the supports are in the right places, and you will get the final answer. And that is all.